Ever wonder what happens to the water and everything else after you flush the toilet or drain the sink? It's a question many of us don't often consider. Well, it doesn't just magically disappear. Instead, it embarks on a hidden journey, a fascinating voyage beneath our cities. This journey takes place through a vast and intricate network of pipes, all carefully laid out beneath our feet. This entire system is truly a marvel of modern engineering, a testament to human ingenuity and planning. It's a silent guardian, quietly protecting our health and safeguarding our environment every single day. The wastewater from our homes initially flows into smaller pipes, the starting point of its underground adventure. From there, it transitions into larger pipes located under the street, gathering more volume as it moves. These pipes are all interconnected, joining together to form a city-wide web, a complex network working in harmony. And this entire network has one ultimate destination, a wastewater treatment plant. Think of it as numerous small streams gradually merging into larger and larger rivers, each contributing to the flow. All of these waterways, big and small, are heading towards one common destination. That destination is the process of cleaning and ultimately returning that water, now purified, back to nature. It's important to remember that before the advent of modern sewer systems, waste often directly polluted our streets and rivers. This pollution led to the rampant spread of disease and created unsanitary living conditions. Today, this vital infrastructure plays a crucial role in keeping our cities safe, healthy, and thriving for everyone. The water that you routinely send down the drain is collectively known as wastewater. This wastewater is a diverse mix of everything, including water from our showers, our sinks in both the kitchen and bathroom, and of course, our toilets. It also includes the water that drains from our washing machines after doing laundry. Each and every flush or drain that we perform in our homes triggers a carefully engineered and multi-stage process designed to handle this wastewater. The primary goal of this process is to effectively separate the waste materials from the water. It also aims to neutralize any harmful germs or bacteria that may be present in the water. And finally, the process ensures that clean, treated water can be safely returned to the environment. So let's follow this essential journey, step by step, and see exactly how it all works, from start to finish. Not all drains are the same, and it's crucial to understand their distinct purposes. The water from your sink, carrying remnants of daily life, and the rainwater on your street, rushing down after a storm, travel through two separate and carefully designed systems, each with its own destination and function. The sanitary sewer carries wastewater, the used water from homes and businesses, to sophisticated treatment plants, where it undergoes a thorough cleaning process. Think of the sanitary sewer as the dirty water highway, a dedicated route for waste to be processed and purified. The storm sewer, also known as a storm drain, efficiently collects rainwater and runoff from our streets and properties, swiftly sending it straight to rivers or lakes, often without any treatment along the way. That's precisely why only clean rain should ever go down storm drains. Introducing anything else, any foreign substance, directly pollutes our precious waterways, impacting aquatic life and our own water sources. Mixing these two distinct systems would overwhelm treatment plants, especially during heavy storms, risking unpleasant and hazardous raw sewage backups or widespread environmental pollution. Keeping these systems meticulously separate ensures efficient and effective wastewater treatment and actively protects our delicate environment. Dumping used motor oil, leftover paint, or even seemingly harmless soapy water into storm drains sends a cocktail of pollution directly to our natural ecosystems, causing lasting damage. Understanding this fundamental difference empowers us all to actively protect our vital water resources. Sanitary sewers are specifically designed for waste that requires thorough treatment and purification, while storm sewers are intended for the rapid and efficient removal of rainwater, needing a quick exit back to nature. Be mindful and aware of what you're putting down any drain. Remember, what goes down the drain can ultimately end up in our rivers, impacting the health of our planet and ourselves. How does wastewater travel miles to a treatment plant? Gravity does most of the work. Pipes are laid at a gentle slope, letting water flow downhill from homes to larger mains and trunk lines, all converging at the lowest point, the treatment plant. But cities aren't always perfectly sloped. Where gravity can't do the job, lift stations, powerful pumps, raise wastewater to higher ground so it can keep flowing. These stations are the unsung heroes, making sure every neighborhood, no matter its elevation, is connected. Without them, many areas couldn't be served by sewers at all. It's a seamless tag team. Gravity pulls, pumps push, and together they deliver wastewater for treatment. This invisible system keeps our cities clean and functioning. Next, let's see what happens when the water arrives at the plant. At the treatment plant, wastewater undergoes a three-stage transformation: primary, secondary, and sometimes tertiary treatment. First, large screens catch debris, things that never should have been flushed. In settling tanks, gravity separates out heavy solids, sludge, and floating scum. This removes about half the solids. Next, in aeration tanks, helpful bacteria break down remaining pollutants, turning waste into harmless substances. The water then enters secondary clarifiers, where clumped bacteria settle out as activated sludge. Some of this is recycled to keep the process going. Secondary treatment removes up to 90% of pollutants. Many communities stop here, but some add a final advanced step, tertiary treatment, for extra purification. The result? Water clean enough to return safely to nature. But what about all that sludge? The solids removed, sludge and scum, don't go to waste. They're sent to digesters where bacteria break them down without oxygen in a process called anaerobic digestion. This reduces volume, kills pathogens, and produces biogas, mainly methane, which many plants use to generate renewable energy. After digestion, the sludge is dewatered, leaving a nutrient-rich material. If treated to high standards, it becomes biosolids, a valuable fertilizer for farms, closing the nutrient loop. This turns waste into a resource, supporting sustainable agriculture and energy. Instead of being a disposal problem, sludge becomes green energy and soil amendment. It's a perfect example of a circular economy in action. Modern sanitation is about more than just disposal, it's about recovery and reuse. Now let's look at the environmental impact of all this. Treating wastewater is essential for protecting the environment and public health. It safeguards our ecosystems from harmful pollutants. However, the treatment process itself is energy-intensive. Pumps that move water, blowers that aerate it, and various other pieces of machinery all require significant power to operate effectively. Many wastewater treatment plants are now working to offset this energy consumption by generating power from biogas, a byproduct of the treatment process. Despite these efforts, most plants still rely heavily on the electrical grid to meet their energy demands, meaning their overall carbon footprint is directly linked to the energy source powering the grid. The more renewable energy sources used, the lower the footprint. Once treated, the water, now called effluent, is released back into the environment, typically into rivers or lakes. Even after undergoing treatment, this effluent can still have an impact on delicate aquatic ecosystems. Subtle temperature changes or the presence of leftover nutrients can sometimes trigger undesirable effects, such as the rapid growth of algae, leading to algal blooms. That's precisely why preventing pollution right at its source is of utmost importance. Even simple, everyday actions, like being mindful about not flushing wipes down the toilet, or pouring fats and grease down the drain, or improperly disposing of household chemicals, can significantly make the wastewater treatment process easier, more efficient, and ultimately, more effective. Practicing proper disposal methods at home plays a vital role in keeping the entire wastewater treatment system running smoothly and optimally, and most importantly, protects the health of our natural environment. Despite its environmental footprint, wastewater treatment remains a huge net positive for our society and the environment, because without it, our rivers, lakes, and other waterways would quickly become overwhelmed by dangerous pollutants and contaminants. And ongoing innovation in the field is continuously making wastewater treatment processes even more efficient and sustainable, allowing us to recover even more valuable resources from what was once considered waste. Every improvement, no matter how small, helps us turn our waste into valuable assets that can be reused and repurposed. Ultimately, the choices we make at home have a significant impact on the long-term health of our rivers, our planet, and future generations. Modern sewers are silent protectors, preventing disease and environmental disaster. Before sewers, cities suffered deadly epidemics from contaminated water. By collecting and treating wastewater, we broke the cycle of disease and made urban life possible. Sewers are the backbone of public health, working every day to keep us safe. They also protect nature. Untreated sewage causes dead zones and harms wildlife. Treatment removes pollutants, preserving clean water for people and ecosystems. Our health and the planet's health are connected by these hidden pipes. Next time you flush, remember the unseen heroes safeguarding our world.